All right, let's practice a couple of these 6.2.2 practice problems where we're now being asked to do these equations in their inverses. So you've got a couple options now. Which way are you leaning towards? We can always do the shortcut table where you tell me what operations are happening to x, and then we undo those operations by doing the opposite. So do you like that little shortcut table, or do you want to just switch the x and y variables and do the longer way, as I'm calling it? But you'll see on a couple of these that the longer way is not very long because there's not very many things happening to the x. So let's go do these first couple the long way. Let's do switch of the x and the y. So as you follow the steps in your previous study guide, we're starting by switching the f of x to a y. We're changing the function notation back to a y output notation. And then step 2, switch the variables. Your x becomes your y becomes your x. And then we need to solve for y again by undoing that positive 12. So we're going to subtract 12. And I'm going to move it to the other side so you can see it as a y equals. I hope you're okay with that switch there. And then we just put it with its function name. My inverse, f of negative 1 of x is equal to x minus 12. How'd you do? Now, if you were doing the shortcut table way, we'd be looking at f of x and f of negative 1 of x in our little table. And we would say, what's happening to the x up here? 12 is being added. Opposite of 12 being added is 12 being subtracted. So all I would do to my function, starting with a base function of x, is minus the 12. And look at my function down here that we already got. So does the table seem like a nice, easy shortcut way for you? Or is the table more confusing to you and you prefer to do the full switching of the x and the y? It's up to you. Let's go do another one. I'm going to use a different color so that it stands out away from the other one. All right. I'm going to put this in terms of y. I'm going to switch the x and the y. And then I'm going to solve for y by working backwards with the operations. Step 1 is adding 2 to both sides. And the last step is multiplying everything by 3. So I'm going to get y equals 3 x plus 2. And notice that I did put parentheses around. 3 is multiplying by everything that we already had there, the whole x plus 2. So we write f of negative 1 of x is equal to 3x plus 2. Okay, this next one says 2x plus 12. Here we go. Now, do you want to pause the video at this point and try this example, number 3, on your own, and then start it back up again and see how you did? That's the way to truly see if you're learning math. See if you can do it on your own. Now that I've got x and y switched, I'm going to start to manipulate the equation, minusing 12, and then dividing by 2. I'm going to get f of negative 1 of x equals x minus 12 over 2. All right, since I'm running out of space for number 4 with my big writing, I think I'm going to go and do the shortcut table method. I've got f of x on this side, f of negative 1 of x on this side, and I've got 2 things happening to x. Now, what do I mean by happening? I mean, if I was going to go plug in a number for x, like f of 1 equals, 3 times 1 minus 4, I would do the 3 times 1 first before I subtract. So the first thing happening is I'm multiplying by 3, and the second thing happening is that I'm subtracting 4. Swoop around, do the opposite to undo what's happening to this x. We're going to say that it's adding 4 and then dividing by 3. Another perspective would be times 1/3. You can use either of these. So now I go write my equation. Let's write this in purple. F of -1 of x. Hang on, I'm kind of running out of space here, everybody. F of -1 of x equals x plus 4 divided by 3. Now, I want to show you the apex key that was attached so you can see the full comparison of over here, where look at the answer I got, x plus 4 over 3, and look at the answer on the apex answer key. When they did the full work, they got x divided by 3 and 4 divided by 3. So it's like they took it a further step and simplified it more than mine. They are both equivalent equations and both answers would be accepted. So I want you to keep in mind that my answer for number 4 is equivalent to the apex answer for number 4. Are you guys okay with that? Let's go down and do the next ones. And again, I think I'm going to show you on these ones the shortcut method so you can kind of still make that decision on which way are you liking. So I'm going to make a table for each one of these functions. And then we're going to write f of -1 of x equals, f of -1 of x equals, etc. All right, so looking in number 5, what is happening to the x? If I plugged in a 1 for x, first we would be multiplying it by 2, then we would be adding 3, then we would be dividing by 6. What's the opposite? Swoop around. We're going to be multiplying by 6, we're going to be subtracting 3, and we're going to be dividing by 2 or timesing by a half. Remember that you can use either of those on this. Go write our function, f of -1 of x equals, we're starting from the bottom to the top. First, we're going to be timesing x by 6, then we're going to be subtracting 3, and then we're going to be dividing by 2. So you can take the entire function and divide it by 2, or you can take the entire function and times it by a half in front. Both of those would be acceptable. Now look at the answer over here on the apex key for number 5. Look at how they took it a step further, and they took half of 6, and they took half of 3, and their equation is 3x minus 3 halves. This equation is correct, and the apex key is correct. Those are equivalent equations. They're just a different way of writing it. All right, let's go do the next table. F of x, f of -1 of x. We're starting with what's happening to this x. It's being multiplied by 2/3, and then 5 is being added. Swoop around. Opposite's going to be subtracting 5 and times the reciprocal. Here's my opposite operations. So f of -1 of x equals, start with your base x value. First, we're going to subtract 5, bottom to top, and then we're going to multiply by the inverse. Go look at the answer, how it's been distributed on the apex key. It says 3 halves x minus 15 halves is the answer because it's been distributed. It's an equivalent equation to what I'm showing you. All right, let's go look at number 7 and number 8 now. First, in this function, let me go get a different color. F of x, f of negative 1 of x. We're talking about x is first being multiplied by 5, and then 15 is being added. So then we're going to do opposite of subtract 15 and divide by 5, or subtract 15 and times 1/5, whichever way you like to think of it. So the answer to this one, f of negative 1 of x, is, hang on, let's try to make this fit. Struggle is real for those of us with big handwriting. F of negative 1 of x equals, start with your base of x. We're going to minus 15 first, and then divide by 5. You can put parentheses or not when it's all in the numerator. It's up to you. Now let's look at the apex key. How the apex key says 1/5 x minus 3. It's divided the 5 out of everything. Okay, last but not least, this number 8. I'm going to do the work up top there. F of x, f of negative 1 of x. First, 5 is being multiplied, then 1 is subtracted, then it's being divided by 2 on that denominator. Swoop around to our opposites, working bottom to top. We're going to be multiplying x by 2, we're going to be adding 1, and then we're going to be dividing by 5, or multiplying by 1/5, however you like to think of that. I'm going to write this answer up here, f of negative 1 of x. I'm going to put a little number 8 over here. And we're going to start with the base of x, and we're going to say first 2 is being multiplied. Next, 1 is being added, and last, it's being divided by 5. Or you could put a 1/5 in front of everything, the quantity 2x plus 1. All right, last two, numbers 9 and 10, they're actually giving you in terms of different variables. Instead of f of x, we're now talking about m of d, or we're talking about a of h. And we're wanting to switch the perspective. The function m of d below relates to the miles Bob can drive his rental car, the numbers of dollars it will cost. It takes as input the number of dollars spent and returns the output of number of miles. M of d equals 40 quantity d minus 35. Write the equation that represents the inverse function d of m, which takes the number of miles driven as input and returns the number of dollars owed. So here I go, taking m of d I'm going to switch this to just m equals, and we're going to solve for d. Step 1, to get rid of this 4, is to divide both sides by 4 so that those cross out. And step 2 is just to add 35. So my new equation is that dollars, or d, equals 1/4 m plus 35. We can rewrite this finally as d of m equals m over 4 plus 35. There's my inverse function. Finally, let's look at one more change of perspective as this application problem. The function below relates the area of a triangle with a given height. It takes the input of height and it gives you the output as the triangle, the area. Now write the equation that represents the inverse. It takes the triangle's area as input and returns the height. Sometimes we're solving for area, but sometimes we want to solve for height. It's just a change in perspective. So let's take the original a of h. Let me change my colors here. Hang on. Uh, 7h over 2. And we're just going to make it an h. I'm sorry, an a. And we're going to solve backwards to get the h by itself, the different perspective. This time I want the height. So 2a equals 7h, divide both sides by 7, and we get that h is equal to 2/7 a. So I now rewrite this as h of a. What is my height in terms of the area? And I can now plug in an input of an area to get the height. I just found the inverse, the opposite, a different perspective.